Awesome. All right, well, looks like everybody got pushed in right here at noon, which is excellent. And so it's wonderful to see you all. I really appreciate you coming to the webinar today. My name is Lindsay, and I'm here with my good friends from Kartoza. I'm here with Gavin Fleming, and we've got Tim Sutton on the line as well. And they're going to be showing off some great stuff today within the open source geospatial realm. And I just wanted to highlight the fact that a couple of logistics here. I'm going to be keeping an eye on, attendees, making sure everybody gets in just fine, which it looks like everybody did. If anybody has any issues at all, if you raise your hand, I can send you a direct message and help you troubleshoot any issues that you're having. We also have the Q&A box. You can type things into the Q&A, but we are going to be kind of hitting the full length of this webinar just with the presentation. We're going to try and do some questions and answers at the end of the presentation. And I'll try to answer Q&As in like typing in the box as well as we move forward. At the end of the presentation, if we don't get to your question, I'll make sure that we get back with you and provide you an answer there. And then besides that, I think I'll go ahead and hand it over to Gavin. He's going to introduce the folks from Kartoza.
Yeah, welcome everyone. Thanks for joining. I'm sitting here in the southern part of South Africa. It's 7 o'clock in the evening, and our friends from the United States, Eastern Time, midday, and I'm sure there are a few other people from other parts of the world, South Africa, Europe. We've got contacts all over the world. So welcome everyone, and this will be recorded for future reference. I've got Tim Sutton with me, who's my business partner in Kartoza, and one of the special people in the QGIS community. And Lindsay, of course, who introduced you, she's our friend and partner in the United States. She works with a company called Focality. And anything that we offer or talk about here, she can talk to you in the States, or we can talk to you, but she's on the ground. And also to mention that I am going to be traveling to the States, to the United States, for the next 2 weeks. I'll be in Atlanta, Seattle, and DC. And if anyone is close to any of those areas, then I'd love to meet you. I'll be with Lindsay. Right, a little bit about Kartoza. We were established in 2014, so we're over 10 years old. But Tim and myself have more than 15 years experience in the GIS industry. On top of that, we work with companies around the world. We've got staff around the world, and we've got offices in South Africa and Portugal. Tim is based in Portugal. We offer products and services built on open source GIS. So our niche is spatial and open source. That sets us apart from most other organizations. We've got really deep technical expertise in the company and lots of contractors and friends who we can work with for extra difficult problems. 30 staff in 10 countries at the moment, and that changes from time to time, but it's very diverse staff, and probably 25 of those are technical staff, geospatial and software development and DevOps. And we also, besides doing commercial work, we make a lot of contributions to the open source ecosystem, which means we contribute code and documentation and organizing efforts to open source GIS projects. The types of activities that we do as a company are web application development, websites, normally with a spatial component. It doesn't always mean a map, but something to do with spatial information. Mobile application development, cell phone apps on any platform. Desktop application development, generally with QGIS. And we do a lot of training and capacity building. We run scheduled courses. We run courses around projects that we do. We run custom courses. We write documentation and training materials. So we are a full service organization. And then hosting and SLAs, service level agreements. We offer hosting, and that's a large part of our business. We host most of the applications that we develop, and we host off-the-shelf applications on behalf of customers as well. And we offer, our hosting includes maintenance, and we also offer support service level agreements. So whether you want support for QGIS or GeoServer or one of the products that we've developed for you, we offer full service. And a special product that we launched recently is called geospatial hosting. There's the URL in the bottom right of the slide. And there is a one-stop shop to get your own GeoNode and various other products hosted by us for you with no hassle. So we serve multiple sectors, economic sectors around the world. We've done big projects in all of those sectors that you see there, and many more. We're not limited to what we do. We try and choose where we can the type of work that we do to be ethical and above board. So a lot of environmental work and humanitarian work and practical day-to-day stuff like running a municipality and farming and mining. Those are all really important. So space and earth observation there are cross-cutting, and something like farming and agriculture is vertical market. So geospatial is cross-cutting, very horizontal, but we have deep expertise and experience in various vertical markets. These are sustainable development goals, and there are, I think, 17 in total, and we have touched on in our work and supported 12 of them that we could pick out from the type of work that we've done. So we try to do work that does good in the world. And the fact that we either directly or indirectly support these sustainable development goals is testament to that. These are some of our clients. We've got probably over 100 clients, and at any time we're working on probably over 20 projects. These are some big names: World Bank, United Nations, Microsoft, Planet Geospatial. Some of those you might not have heard of, but look them up. If you want to know who else we've worked for, they're more on our website, and we can give you a full list. But it's really we work for everyone from big governments, NGOs, right down to small companies and even schools and universities and individuals. So you might want a bit of support for your personal project. You might be a single person startup, or you might just want to come on a training course. So we really have a diverse range of customers. Right, what can you do with the open source geospatial stack? Stack is the components that make up the system. It's a bit of a jargon term, but you'll see it appear several times. And we see these blocks as the main components of a modern geospatial system, or GIS, Geographic Information System. We haven't put the brand names and logos of all the different software that we use. We decided not to clutter the presentation with those. We've kept it very much branded Kartoza, but there's lots of different software behind what we do. And those are the general compartments of how we see a GIS. There's the sort of web front end, user interface stuff, whether it's cataloging data or portal to your data or analytics and visualization. Enterprise RDBMS, Relational Database Management System. Serious database we tend to use is PostgreSQL, which is a slot-in replacement for things like Oracle. It's just as capable as a normal database and for spatial data. Mobile apps and field capture, we develop, well, a system comprises apps to, most people interact on their mobile devices, but mobile devices are also used for field data capture. So both of those are covered in the mobile domain. And then desktop GIS is, most people possibly think of GIS, they think of a desktop GIS. So that is still a major part of the ecosystem. And then these days, what glues it all together generally is something in the cloud. We've got servers or hosts in the cloud that run databases, web servers, interactive maps, all sorts of other things going on in the cloud. And the new piece of jargon around that is cloud native. So there are very efficient new ways of working with geospatial and other data that mean that you don't have to move data. You don't have to move massive data sets from your desktop into the cloud and back again to do analysis. You can do everything in the cloud and just talk to that from your desktop or from another. So that's the general arrangement. Then diving straight into some cool things that you can do with GIS and with open source GIS. So open source GIS can really slot in for any type of GIS work that anyone does with any other proprietary software. Open source GIS ticks all the boxes. A lot of people, when they think of GIS, they think of digital maps or mapping. And yes, of course, cartography and mapping is a very important part of GIS. These are some maps that we made in Kartoza. Waterberg is a mountainous area in northern South Africa. And these were a series of tourism maps that we did for the local tourist organization, and they are expanded to wall size and stuck up on walls of restaurants and tourist hotspots all over that area. And there's a whole series of these maps, and the client is very happy with them, the public is very happy, they're beautiful, they're informative, and that was all done in QGIS. The one on the left is a project we did to digitize for Zimbabwe and Mozambique the hydrogeological paper maps that came from, I don't know, 50 years ago. We had to scan them, georeference them, and digitize all the detail, thousands and thousands of polygons, and style them correctly to be scientifically correct maps. There's the Mozambican one on the left there, the equivalent, and that little inset shows a scan of the original paper map versus the rendered version from QGIS of the digitized data symbolized to try and match the original paper map. And if any of you have seen a geological map in detail, you'll know it's very complicated symbology. And then the one on the right is a big project we did with biodiversity and other data, originally in that Waterberg area, but then for the whole country, doing overlay analysis of different types of data to assess biodiversity hotspots and presence across South Africa. So that's a scientifically useful map, but also very beautiful cartography. And then these are some examples from the QGIS community that we didn't do in Kartoza, but just to illustrate the high level quality and professionalism of cartography that one can achieve with QGIS. And there's some more. There's really an endless variety of styles and things that you can do with really is totally up to your imagination. Why open source? Most of you are probably here because you do geospatial, but you probably intrigued by open source if you don't use it already. And so why would you want to use open source? There are several reasons, and they could deserve a whole presentation on their own. But just to summarize a few important ones that make a difference when companies are making decisions. The most obvious one is that there are no license fees. The software is absolutely free. It's free of cost, and it's free to do with as you wish. Absolutely no limit generally. There are some different licenses that have some types of restrictions, but most of them you can do absolutely anything you like. Whereas with proprietary software or privative software, you get charged per seat or per extra user. So they're generally very expensive to start with. And then as soon as you want to scale, costs can go through the roof and become really prohibitive. And one thing that's not mentioned here is vendor lock-in. So with open source, you don't get any vendor lock-in. because there are no vendors. If Kartoza does a job for you with open source software and you don't like what we did, or you want to hire someone else, you can, because the software doesn't belong to anyone. Whereas with proprietary software, you can be totally locked into a particular vendor because there's no substitute from another vendor that can just swap out. Flexible support bundles, it's totally flexible how we offer support, or another company could offer support, whereas often with proprietary software, support comes bundled with the software licenses per seat, so your costs escalate per seat. When it comes to data sovereignty, that's not so much about software, but it's about maybe making data easy to upload and access in that little ecosystem that you've bought in the proprietary software, but very difficult to export and download and share outside that system. Whereas with an open source stack, an open source platform, you have complete control of your own data and what happens to it. Another important thing is with the code of open source data, you can make changes yourself, or you can hire a developer to make changes. So if there's something, it could be a bug, it could be a new feature you want, you can implement that immediately or at very short notice. You don't have to wait for a vendor to decide if they want to do that and when they want to do it. You've got complete control over new features and fixes in the upstream product. The upstream product is the open source product that you are using. Right, the stack, mentioned that word. We're going to take you through a little journey of a typical enterprise GIS setup to try and touch on a lot of the components that a typical large organization needs in its daily operations. And it's not we're going to have some field data capture where we capture points and polygons around the world, but it's not focused on a particular vertical market or particular geography. So let's dive into that. So there's our little blocks of the open source GIS system on the right. A large part of this, in which you'll see at the end, is that an open source system can interact and integrate completely with either a new or existing proprietary system. So if you have ArcGIS or Google Earth or any other proprietary system, you can use open source components along with that. You can migrate to open source. They can live very, very happily together. And they're definitely not mutually exclusive. But to do that properly, things generally do depend on using interoperable standards-based services, which open source comes with by default and generally are available but optional in the proprietary world. Okay, to start with, we're going to look at a scenario where we've got QGIS desktop and a field data capture application called MerginMaps. And we'll bring in other components of the system, but we're going to start looking at what happens in QGIS. In this instance, we have already set up the project and the forms that are going to be used. And here's a scenario where the user has got the project on QGIS and they are capturing, in this case, points. You can see a bunch of points have already been captured all over the world. And it's totally normal GIS workflows that you might have in your organization. So this case is a desktop user, and they are right there synchronizing their data with the MerginMaps hub, which you'll see in a minute. Now they've gone over to the United States and captured a polygon in another layer and carry on doing the normal work, capturing data, editing it, and synchronizing it with the MerginMaps server. So the MerginMaps server sits on in the cloud and acts as the sort of agent, the coordinating, the collator of data coming in from all the different users. So here's one user on a desktop using QGIS, and other users could also be doing the same thing at the same time, editing on their desktops with QGIS, doing different work. And the MerginMaps hub, which we'll see in a minute, handles all of the potential conflicts and merges all the data together, hence the name. So they
Yeah,
say
well,
it's a project. Yes, Tim.
just to add to that, one of the really exciting things about these workflows that we're showing you is that you can learn one application, QGIS, transfer that knowledge into the mobile application development. So all the work that you do in building forms and validation routines and so on, they all transfer themselves into the Mergin workflow and then make themselves available into the mobile app as well.
Yeah, so the MerginMaps app, which you'll see now, is actually QGIS. So it's QGIS on your phone. It might look a bit different, but you'll see the map is exactly the same. And then the Mergin Cloud, which you'll see later, is also serving up its data with QGIS server. So QGIS all the way through. So settings up once in QGIS, and the way you work and the type of data, there's no issues all the way through your whole workflow. So now we're going to see basically the same operation happening on a mobile device in the MerginMaps app. And there you can see the data has been synced. That's exactly the same data that we had on the QGIS desktop. And there the person is just browsing around and inspecting it. You can look at the attributes of the data, you can edit data, you can capture data, you can walk around and capture a polygon. In this case, zoomed into Tunisia to capture a new point of interest. But normally you'd be walking around on the ground, and if each new record that you capture creates a point at that location. And you can plug in or use Bluetooth to connect a professional, more accurate GNSS device. If you think that your mobile device's position is not accurate enough, you can use more accurate devices to get a better position. So there, that point has just been captured. That little form, by the way, with the two fields, that was set up in QGIS. And what gets synchronized is the QGIS project and the data. All right, now we're going to look at the Mergin Cloud, where everything gets sent to. So from the desktop and from the MerginMaps app, got sent to MerginMaps hub. Now this is a web application running in the cloud. You can actually self-host it. There's an open source community edition that you can self-host. And there we go. This is QGIS server serving up the data. So this is a map view of that same data. You can look, this is every single commit or sync that was pushed by every single user from desktop, mobile devices, all the different clients. Got a full history. If there are conflicts, you can resolve those there in that platform. Now we want to get the data from Mergin Cloud. We've just had it on desktop, so all the different users with their desktops and mobile devices have access to that data. What if we want to use it across the organization in other applications? There's a little component of Mergin called MerginDB Sync that synchronizes whatever's coming in from the users into a Postgres database, into your enterprise RDBMS. And from there, it can be used in absolutely any application that can connect to a database. And in this case, we connect to it from GeoNode, which you'll hear quite a bit more about later. And GeoNode comes with a web map server called GeoServer. And together, they make up or can be considered to be your spatial data infrastructure. So GeoNode is connecting to the database. And here we see that same data in GeoNode. And that website there, mygeocommunity.org, is public. It's run by us, and you can go and play around with yourself. So This is a dashboard. GeoNode, you can make dashboards. It is a portal, a catalog of different data sets. You can use it to manage data, all your different layers. In this case, I'm just going to pause it a little bit because there's lots going on here. It's not just a layer or map. There are actually two layers here. There's the points, they're styled differently, but it's the same data. There's a little gray square now. So that's the data we're familiar with from previously, but there's also now this red buffer, red circle around that point. Now that is a dynamically generated buffer that Tim set up in the database, which creates a layer dynamically. So it doesn't even exist, was never captured, but it creates that buffer automatically in the database and then serves it up as another layer. So there's all sorts of interesting things you can do with your data dynamically. And then on the GeoNode side, you might have noticed you can do dashboards, geostories, all sorts of analytics and visualizations in GeoNode. Here, the dashboard is showing you on the right how many records are in the map on your screen and various other statistics. You've got an inset map, you've got description on the left. So there's an example of a business information dashboard that you could create on the data in your company or your organization. Once you have GeoNode, and GeoNode itself is an open source system. Okay. Right. This is, did we skip something? This is GeoStory, which is also made in GeoNode. And you might be familiar with story maps and map stories that other systems have. This is the equivalent in GeoNode. And this GeoStory encapsulates everything we've just covered around MerginMaps, field data capture, and GeoNode, and tells you the story of that. You can incorporate any media you like, including interactive maps from your own system, documents, videos, and that's the GeoStory. And it is available on that mygeocommunity.org site, so you can go and look at it yourself later. Now we're going to show the interaction. Well, we've got all that set up in our system, but we've got some users that have Google Earth and Arctis Online. So how do they get to see that data? Here's an example with Google Earth Pro. And the data that's in GeoNode is published in various ways. In this case, we're connecting to the WMS, Web Map Service endpoint of that point of interest layer in Google Earth Pro. And normally you would use that for image data. GeoNode can also publish KML and GeoJSON and other formats, which would be more appropriate for vector data, which is the points and the polygons that we're talking about. So that's why it looks a bit rough there and it takes a while to load because of the connection, I think, where Tim was when he was making this, but what it will refresh there. So there are those same points of interest coming in Google Earth in exactly the right place with all their attribute information. And when a new point gets collected, it will appear in Google Earth immediately. And similarly, Arctis Online, we have the same scenario. Then Arctis Online, we're adding exactly the same WMS endpoint, mygeocommunity.org, choosing that area layer and the point of interest layer. You can see it's got the whole list of all those layers in that whole catalog. And there, this was a much quicker connection. There are those same points coming through into Arctis Online and those polygons. So there, that's the full cycle of integration of all the different components. So hopefully that gives you a clear idea how powerful open source GIS is, and that it can do all the different things that you need to do in your organization. Now we're moving on to hosting and SLAs. This is our platform which we launched last year, called geospatialhosting.com. And it's showing you the page for GeoNode, because that is live. There's several other applications that you will be able to host yourself through geospatial hosting coming soon. But the idea is that you go there and you choose, you want a GeoNode, you choose what size GeoNode you want, you pay for it, and it gets deployed in literally a few minutes, and you get an email with your own username and login and access to your very own GeoNode. And as long as you pay for your hosting, it will stay up. We've got very sophisticated Kubernetes-based DevOps infrastructure that we deploy on DigitalOcean. Google Cloud, Amazon, and others are available soon. At the moment on DigitalOcean. But we've got full monitoring and alerts, and what sets us apart for service like this is that we include user support. Okay, maintenance is a given. We'll keep the system up and running and updated, but we also include user support there 4 hours, 2 hours per month, 4 hours per month. So that you can ask us any question or any help. How do I do this? Or this isn't working, or set this up for me, please. You've got that available. Right. Now to move into some examples of work and projects that we have done with open source. This is a selection of QGIS plugins. If you know QGIS, you'll know that you can extend it with plugins. There are probably a few thousand plugins available now from the community, and a lot of them do very serious work, and most of them are paid for by customers. For example, that Stack API browser at the top right there was paid for by Microsoft. And there are others that we've done that didn't appear here because our name is not credited, but there are quite a few more. And this is just looking at the plugins, the QGIS plugins website. If you in QGIS itself, you'll see it in the plugin manager, you'll see the list of plugins. But this website, which is the sort of portal and catalog and organizer for all the plugins, is also built and developed by Kartoza. We build and maintain it. So we do the platform. We're very, very, very involved in the QGIS community. In fact, we have 2 staff who we employ on behalf of QGIS to run the infrastructure and documentation and various other aspects of the QGIS project. Another example is the QGIS Hub, which is another website which we maintain for the QGIS community. And that is a hub of all sorts of different resources that you can use and download to help you do stuff in QGIS. In this case, it's a particular project that Tim actually built. So you download the project, load up your data into it, and it gives you those dashboard indicators right inside your desktop, counting and summarizing and doing BI type of stuff on the data that's in your canvas. This is a platform that we've been working on for the last few years for UNICEF, and it's a geospatial first, a map-centric business information platform that UNICEF uses in production at the moment in places like Ukraine and Gaza and all around the world, wherever they are working. The data that they use and analyze to make their daily decisions and monitor what's going on is all in this platform that we built for them. And it is also open source. So you can host it yourself, you can modify it, you can pay us to host it for you. So as you can see, it can do all sorts of graphs and analytics and visualizations of very rich attribute-rich spatial data. Here we have another project that we've just finished for the World Bank. This one is focused on enhancing access of women to economic opportunities. So maybe you want to talk us through it.
Yeah, thank you. The idea with this plugin is to provide a platform for doing multi-criteria analysis, where you've got many different factors that influence the accessibility of areas to women in the economic playing field. And the plugin sort of walks you through the whole process of setting up the analysis and then computing the sort of scoring each area to indicate which areas are highly accessible or which areas are inaccessible for women, and also lets you map areas where you're doing interventions, and the whole thing was built using QGIS just as an open source plugin for anybody who wants to use it.
Yeah, so it's on the next slide, but still, it's like any plugin, that whole key system, if you in QGIS now, go to the plugin manager and you'll see it there, download Keystone, and then it'll guide you through what Tim's just shown you. Right. Tim should probably also talk about this project we
happy to jump in.
with the Freshwater Research Centre.
Yes, so this is one of our marquee projects that we've been working on in collaboration with the Freshwater Research Centre. And it started out with them coming to us and complaining that they'd built a legacy system where the data was locked in the old system, and people that had developed it had disappeared, and the technology that was used was defunct. And we helped them to migrate it into an open source platform, and built up the platform as a mapping platform for just visualizing where the biodiversity data is. But also built this whole collection of rich dashboards and river health assessment tools. What you're looking at now on the screen is a river health scoring system called SAS. And the project was so successful that it was then rolled out into different organizations in countries, mainly around Africa, although we've got a couple in Europe as well. It's all open source again. But what's interesting with this is we built a sort of multi-tenant model so that we can actually have all of the different stakeholders sustain the central project. And as new participants arrive in the project, they kind of the consulting and development work we do for them contributes into the underlying project that everybody else gets to benefit from. And now we've got millions and millions of biodiversity records, as well as pesticide pollution and river sensitivity data on this platform. And each tenant that has their own instance has a content management system where they can brand it and present it and customize it as they want to.
Yeah, it's been deployed for South African national parks, Botswana, Okavango, various institutes in Europe, Rwanda, all over the place. And the funders from the United States, GIS, they said that any biodiversity project in Africa that needs an information system must actually use this. So I'm very proud of it. Skip, there we go. Right now, my Civitas is now a totally different vertical market. This is all about asset management. And there's a company called Land Info Technologies we've worked with for the last few years. They do on the ground stuff, and they were doing it with QGIS and spreadsheets to set up asset management systems for little municipalities, towns, and communities in Canada. And they came to us to build a web front end and proper database integration. So we helped them do that, and we together built this product called MyCivitas, and it's running in about 100 small towns across Canada. But it can be actually deployed anywhere in the world in a similar situation. So it's a very lightweight asset management system, an asset lifestyle tracker. So obviously you need to put in the right information, where are your assets, when were they installed, all those sort of typical asset management things, what does they cost? And then it tracks when should you replace them, what is the probability of failure, risk of failure, and so forth. We've got a bit of a video about that. And it's gone through various iterations in its life. It's even got a cemetery management system now. But there we have water, wastewater, roads, pretty much any asset can be managed in it. And yeah, we're creating a job ticket to send someone to go and do some maintenance on a particular asset. And you can choose which asset you want to look at and what view of that asset you want to see. And it's just very quick and easy to view your assets and browse around and manage your assets as a small municipality. I know in South Africa it's a legal requirement to do that, and there's lots of very expensive systems and complicated systems to do it. But this is very, very simple and easy to implement. There's the ticket list of jobs. So it's integrated with the ticket management system. And you can track, did the person do their job? How's it going? They can give feedback. And then that gets updated in the system and it shows the new status. You view the data as a map or as a table. And of course, it's protected for links for authorized users. And there are multiple towns in there. So yeah, we can see, as admins, we can see any town, but if you're a registered user for that town, you can only see that town's information. I mentioned security. All the systems that we do, especially that geospatial hosting and ones that we host, we've got a dedicated DevOps team. So besides the sophisticated infrastructure, we are very concerned and careful about security and know how to make modern systems secure in a modern way. So there's lots going on here. There's maps, there's graphs, charts, visualizations, tables, and all of that has been driven by the users. It is useful for the users. There's another application in the mining realm, although it could be used elsewhere. Anywhere where ground subsidence is a risk. In this case, our partner in Canada, also ex-South African, has a company called EO Intelligence, and he's the expert in synthetic aperture radar processing and analysis, very complicated stuff. But what this does is uses free Sentinel synthetic aperture radar rather than very expensive Terrasar or other commercial satellite data. And in this case, it's showing a mine in Australia where there was a tailings dam collapse, and a lot of damage was caused by that. So what a system like this does is every time the satellite passes over, it processes it and looks for movement. You can detect movement up to from a few millimeters up or down. So you want to look at movement of, in this case, tailings dam walls before they fail. So if you can detect little bits of movement in certain directions, you can go and do something about it before there's a failure and the disaster. So mines and other organizations are prepared to pay to have those solutions in place. Then this is another remote sensing related project that we've been working for many years with our friends at Spino Lakes. Again, Matthew at Sinalex is the scientist, and he developed the very sophisticated processes to detect cyanobacteria and other things in water. And he's got an application. You can go to Sinalex and sign up to any dam in the world. And here Tim is doing it in Portugal. And it will tell you its current status and its historical status as far as chlorophyll levels, surface vegetation, cyanobacteria, which is a major pollution indicator. And too much cyanobacteria means the water is unsafe to swim in, unsafe to drink, unsafe for recreation. So a lot of big water organizations in Australia and around the world are paying for this to monitor their water bodies. And I think this is my final showcase item. Collaboration with South African Geography Teachers Association, Southern African. We built this map downloader. Now, teachers often want topographic maps for teaching purposes or to set examinations. And we thought we could do this pretty easily with QGIS. So we got another QGIS web client. I talked about G3W earlier, that your intelligence app was G3W. This is LizMap. And we've essentially got a QGIS project there. We've got topographic maps being served, called together into this application. And the user can come in and choose what size map they want, what orientation, what scale. You can choose the area they want it in. And once they're happy with the map they want, then they just press print. You give it a title there. And there's various other tools here. You can do an elevation profile. You turn on various different layers. You can make an orthophoto map. You can make what we call a hybrid map, which is orthophoto merged with the topographical data. And then printing, and you're going to see the so QGIS servers on the background, and it's on the fly generated this map. So the teacher or whoever it is gets the topographic map instantly for exactly their purposes. And thank you very much. That's it. There's time for questions or comments or any other thing you want to add, Tim or Lindsay.
Yeah, thank you so much, Gavin. That was wonderful. Hopefully everybody got some good information on the capabilities of open source GIS. I know there's often the incorrect idea that it's just a couple of people in their basements working on some projects here and there, and you can actually really truly get an amazingly advanced enterprise system out of all of the different open source products that are out there. We do have a question and answer time now. If you raise your hand, we can take your questions. You can also put them in the Q&A box. I'll give it a minute or two here to see if anybody has any questions. If you don't, no problem at all. This webinar has been recorded and it'll be sent directly to you. If you have any questions, we'll have all of the contact information within that email. And then in addition to that, I know on our invite, some folks had selected that they would like a follow-up, and we'll make sure that we are able to follow up with you. So any questions at this time? All right. Well, in that case, I really appreciate you all being here. Thank you so much, Gavin. That was a wonderful webinar, and thank you so much, Tim, as well. And as I mentioned, you all will be getting some follow-up emails with information and the webinar link as well. So I hope you all have a wonderful day, and we'll be ending the webinar now. Thank you again, Gavin.
Great. Thanks, Lindsay. Thanks, Tim. Thanks, everyone, for attending.
Thank you very much, everybody.
Bye.